Would you like to know more about Pentax Medical's commitment to infection prevention? Read more about our hygiene commitment on our website.
Today he is going to address a new product combined with new process, and that in the light of the importance of drying. Well, Daniel, welcome. I see you've joined us. Please take it away.
Hello from Paris, France, and I am really very glad to participate to the hygiene event organized by Pentax Medical, and also to have a so nice audience from so many countries. So today I will present you a new product combined with the new processes for the endoscope drying and storage. On this slide, I presented the main steps of the reprocessing of the flexible endoscopes. So the bedside cleaning, the manual cleaning, the washing and disinfection, and finally the drying and the storage. So every reprocessing step is crucial. When one step fails, the endoscope hygiene is compromised. So we have to pay attention to the whole process, as this morning the key speakers mentioned also. So the hygiene is very important when the steps are correctly done. Now we are focusing on the drying and the storage. Drying is very often neglected, and in different countries, the guidelines do not impose drying if an endoscope is used within a few hours. So recent studies, and I think this morning the key speakers mentioned also, the drying minimizes the risk of infections and also prevent the creation of the biofilm. Pentax Medical and Plasma Biotics developed an innovative product, the Plasma Typhoon, for ultra-fast drying of the endoscope and active storage inside the single-use recipient plasma bag. So with Plasma Typhoon, we are reinventing really the drying and the storage. So we have an ultra-fast and complete drying of the endoscopes, and this just in 1 to 5 minutes, depending on the endoscope type, the number of channels, the diameter and the length of the channels. After the drying, we can perform also an active storage of the endoscope inside plasma bag, which allows to keep the disinfection state of the endoscope up to 31 days. I have to mention also that the maximum storage time may be subject to the local regulation. So with these options, drying and storage, we can improve the patient safety by eliminating the risk of the cross-contamination or the contamination on storage and transport. So why is the product so fast and efficient? So Plasma Typhoon is so fast and efficient for 3 main reasons. So the first one, we have a patented 2-step process. So firstly, we have a laminar flow, which allows to eliminate the water from the channels smoothly without droplet fragmentation inside the channels. This step is followed by a second one, a turbulent, heated flow, which dries the channel's walls, and the flow is up to 200 km/h velocity as a typhoon, and which explains the name of our product, the Plasma Typhoon. So a second important thing is the medical air grade injection, which is done simultaneously in all channels. And finally, we have a connection set which is perfectly airtight. So the flow coming from the system, from Plasma Typhoon, go inside the channels without leakage outside in order to have the right velocity, the right temperature, and the right flow rate in order to have an efficient drying. So how about the validation? So the product was validated following the European standard 16442 on Pentax Medical, Fujifilm, and Olympus devices. We use for the validation GI scopes, ultrasound scopes, and also bronchoscopes. What is important is the fact that Plasma Biotics went further and developed new methods in order to check the effectiveness of the drying. For example, we use open endoscopes where we could inject colored water and to see inside how the process works. And very often I got a message or a remark, it's too simple to be true. So using open endoscopes where we put colored water and launching the process so we can demonstrate in live how the system works and the efficiency of the drying. Also, we use inspection of the internal part of the channels. For undried channels, we can see here some droplets. And also here on the second pictures, we can see after the drying with plasma typhoon, no more droplets. We use also sensitive water paper, cobalt chloride, which allows to check that the drying is done also on the external part and also on the inlets of the endoscopes. So why in active storage? So the process for the storage is the following. Firstly, we dry the channels with the plasma typhoon. The external part is done by the operator using air gun or a lint-free cloth. After this, we have to place the scopes in the plasma bag, and the plasma typhoon will generate a plasma which is insufflated into the bag during a very, very short cycle, 5 seconds. So the plasma contains active species, including ozone molecules, which create an aseptic atmosphere inside the bag. So we summarize in this drawing how it works, the plasma generation. So we have in the system a medical air flow, which is activated thanks to 2 electrodes, which are creating a high voltage discharge, and active species, including O3, with biocidal effect, are injected inside the bag. What is also important is the fact that the ozone is injected only in the bag, is not harmful for the user, which is outside, and also the ozone will act, and after 5 minutes, it will recombine in oxygen. So regarding the storage validation, once again, we use the European standard 16442 on Pentax Medical, Fujifilm, and Olympus devices. We tried also GI scopes, ultrasound scopes, and the bronchoscopes. And the protocol, it's very complex. We have artificial contamination of the scopes with Pseudomonas aeruginosa. So we have this level, the line, green line, and the system is validated if after the storage, the microbiological counts are under the green line. And as you can see, the results from test 2, 1 day, 2 days, 3 days, 7 days, and up to 31 days, we have 0 contamination. We compare also our system with an air gun drying, so the red curve. So the scope was dried with an air gun and stored outside, not in the plasma bag. So in this case, we have a high growing of the initial inoculation with Pseudomonas aeruginosa from roughly 4 logarithms to up to 10 logarithms. So in addition to these validations, we did also clinical studies, and essentially in France, we launched the product in France. So we have a clinical validation in Hôpital Pitié-Salpêtrière in Paris, and we have also a clinical validation at European Hospital Georges Pompidou from Paris. So the role of the ozone. So for the European norm, only the Pseudomonas aeruginosa is mandatory. So we know that this pathogen is sensitive essentially to desiccation. So if we dry correctly the channels, Pseudomonas aeruginosa will disappear. So plasma biotics went further and demonstrated also a biocidal effect of the ozone inside plasma bag. So we contaminated internally the plasma bag with different pathogens, E. coli, Candida albicans, Aspergillus brasiliensis. And for this low contamination, we obtain 1 to 2 logarithm of reduction. So the next steps, and some works are undergoing, is to evaluate the virucidal effect of the ozone. So already demonstrated on coronavirus 229E, so we obtain 98.7 reduction of the contamination. So next steps is to use other viruses. We are working with a French laboratory from the RFR in Toulouse, and we have to check the interest for endoscope storage and also for other medical devices. So in conclusion, I presented you the Plasma Typhoon, a new product which allows with a simple process to minimize the risk of infections thanks to a fast and effective drying. And to prevent the biofilm creation, we have an active storage inside plasma bag where, thanks to a closed, dry, dust-free environment, we ensure the preservation of the disinfection state of your endoscopes. Very important, the product is available at point of care due to this individual protective environment, and this allows to improve the efficiency, ensure a flexible capacity and reduction of repeated processing of the endoscopes. So I'm very happy to share with you a testimonial from the University Hospital from Nantes, and I would like to thank to Professor Didier Lepelletier and Madame Baudet, the chief nurse, which share with us the experience of this important hospital from France with the product Plasma Typhoon. So please play the video.
Bonjour, je suis Didier Lepelletier, je suis professeur d'hygiène hospitalière et le responsable du centre de traitement des endoscopes souples thermosensibles dans lequel nous nous trouvons. Effectivement, ça fait 5 ans que nous utilisons votre produit. Tout d'abord pour le séchage, pour des questions de qualité de désinfection et de séchage des canaux des endoscopes et d'ergonomie du travail des soignants qui travaillent ici, et également pour le stockage, puisque nous sommes à distance de centres utilisateurs d'endoscopes et que nous utilisons le plasma bag pour stocker les endoscopes à distance de notre centre.
Donc, je suis Nathalie Baudet, je suis cadre infirmier sur le CETRES, qui est le centre de traitement des endoscopes souples sur le CHU de Nantes. Le passage à l'utilisation du Plasma Typhoon et du Plasma Bag a été très facile puisque c'est du matériel qui est facile à utiliser, moyennant un temps de formation très court. Le Plasma Typhoon nous a permis d'assurer un séchage très efficace et on sait que le séchage est un des éléments déterminants pour éviter la recontamination d'un endoscope. La sécurité microbiologique de nos endoscopes a été renforcée grâce au séchage réalisé par le Plasma Typhoon. L'enséchage dans les plasma bags nous assure de mettre l'endoscope dans un environnement aseptique et donc d'éviter toute recontamination dans les 7 jours qui suivent. Le plasma Typhoon assure un séchage parfait. Ça, c'est vraiment contrôlé au niveau microbiologique. L'avantage aussi que nous apporte le système Plasma Bag, c'est de pouvoir mettre au sein des services, par exemple dans les unités de réanimation ou de soins intensifs, directement les endoscopes dans leur sachet Plasma Bag, les endoscopes prêts à l'emploi au plus près de l'acte d'endoscopie.
Nous avons observé une augmentation de la conformité de nos prélèvements, puisque nous sommes passés de 40% de conformité en 2013 à 84% en 2019.
Les agents du CETRES sèchent l'extérieur de l'endoscope en utilisant des lingettes non pelucheuses et en utilisant aussi la soufflette d'air comprimé, d'air médical, afin de bien sécher les infractuosités des endoscopes.
En conclusion, nous sommes très satisfaits de l'utilisation de ce système Plasma Typhon et Plasma Bag, à la fois pour le séchage, puisqu'il améliore les conditions de travail du personnel et qui réduit significativement le biofilm, et pour le côté stockage, il permet de stocker davantage d'endoscopes et de nous focaliser sur d'autres étapes du traitement des endoscopes.
Time to ask some questions to Danielle. Are you ready, Danielle?